Welcome back to MBSE Simplified. In the previous video, we focused on how to write good, verifiable system requirements, making them clear, measurable, and usable by engineering teams. But writing good requirements is only part of the challenge. Today, we answer the questions: how do those requirements connect to the rest of the system? And how do we keep track of them so nothing falls through the cracks? Because requirements don't exist in isolation. They drive behavior, they shape architecture, they define what must be verified, and without clear connections between those elements, systems begin to drift. In this video, we'll explore requirements traceability in MBSE, why it matters, how it works, and how it enables real engineering decision-making, why it's one of the highest leverage practices in systems engineering, and exactly how it works inside a real model. If you've ever hunted for a missing requirement, struggled with change impact, or spent hours updating spreadsheets that were already outdated, this video will change how you approach your next project. Let's turn your well-written requirements into a living, connected system map. 1. What traceability really is. Traceability is often misunderstood. It's not just documentation. It's not just linking IDs in a spreadsheet. Traceability is the practice of creating and maintaining explicit relationships between requirements and everything else in your project. In simple terms, traceability is about understanding relationships across the system. At its core, traceability answers one question: why does this exist? Why does this function exist? Why does this component exist? Why are we verifying this behavior? If you can't answer those questions clearly, traceability is missing. Traceability can also answer the following questions at any moment. Forward trace: which design elements, behaviors, and tests satisfy this requirement? Backward trace: why does this design element or test exist? Which requirement drives it? In traditional document-based approaches, this meant giant Excel matrices that quickly became stale. In MBSE, traceability becomes living relationships inside the model itself. The model knows the connections automatically. No manual spreadsheet updates required. Traceability connects the core elements of the system. The typical chain looks like this: requirement to behavior to structure to verification. Let's break that down. Requirements define what the system must achieve. Behavior defines what the system must do to satisfy those requirements. Structure defines the components that enable that behavior. Verification confirms the requirement has been met. Traceability connects intent to implementation and back again. 2. Why traceability matters, especially in MBSE. So why is this important? Because systems change, requirements evolve, design decisions shift, new constraints emerge. Traceability enables impact analysis. If a requirement changes, you can immediately see which behaviors are affected, which components are impacted, which tests must be updated. Without traceability, teams rely on assumptions, dependencies are missed, integration issues increase. Here's why this is a game changer once you're working in a model. 1. Early gap detection. You can instantly see which requirements have no satisfying design or verification before CDR or integration. 2. Change impact analysis becomes fast. Customer changes a requirement, the model immediately shows every affected block, interface, behavior, and test. No more surprise rework. 3. Single source of truth. Requirements, architecture, behavior, and verification all live together. Updates propagate naturally. 4. Verification and compliance proof. You can generate a complete traceability report for auditors or certification in minutes. 5. Better decision-making. Trade studies, risk assessments, and reuse decisions are grounded in real linkages instead of assumptions. In short, good requirements from the last video give you a strong foundation. Traceability gives you control over the entire model. Without traceability, systems don't fail immediately, they fail later. 3. What breaks without traceability? Let's look at common failure points. Orphaned components. Parts of the system exist with no clear purpose. Misaligned architecture. Design decisions don't match requirements. Incomplete verification.
Tests exist, but they don't fully validate system intent. Model drift. Over time, the system model no longer reflects the actual system. These issues are not modeling problems, they are traceability problems. 4. How MBSE enables traceability. This is where MBSE provides real value. Instead of manually tracking relationships, the model captures them.
In SysML, traceability is expressed through relationship types instead of spreadsheets.
The 4 you will use the most are satisfy. Design satisfies a requirement. Example, battery block, satisfy, system shall operate for 8 hours. Verify, test or analysis proves the requirement. Example, battery life simulation, verify the same requirement. Derive rect, high-level requirement spawns child requirements. Example, system shall be portable, derives weight less than 2 kilograms and battery life greater than 8 hours. Trace/refine, supporting or looser connections when full satisfy or verify isn't yet defined. In other words, a requirement is satisfied by a block. A requirement is realized through behavior. A requirement is verified by a test case. You can create these links directly in requirement diagrams or simply drag relationships between elements anywhere in the model. Modern tools, Cameo, Rhapsody, Capella, etc., automatically maintain the matrix and highlight missing or broken links. These relationships are not just links, they form a network of system understanding. 5. Practical examples, satellite telemetry. Let's use the telemetry example from the last video. Stakeholder intent, well-written requirement. The satellite shall transmit telemetry to ground stations within 2 seconds under nominal conditions. In the model, this requirement derives 3 child requirements: data formatting, antenna pointing, and transmitter power. Each child is satisfied by specific blocks and behaviors. Dedicated test cases verify them. Now the customer tightens it to 1.5 seconds. You update the parent requirement, the model instantly flags the impacted blocks, derived requirements, and tests. You know exactly what needs attention. No guesswork, no hidden ripple effects. Traceability would connect this to a communication function, behavior, a communication subsystem, structure, and a timing test, verification. You immediately know behavior may need to change, architecture may need upgrades, tests must be updated. That's the power of traceability. 6. Engineering discipline. Traceability is not automatic, it requires discipline. You need to create relationships intentionally, maintain them as the model evolves, and review them regularly. But when done correctly, it becomes one of the most powerful aspects of MBSE. OOSEM connection. This is also why structured methods like OOSEM emphasize traceability throughout the lifecycle. OOSEM doesn't treat requirements, behavior, and architecture as separate steps. It connects them through a structured flow. That ensures requirements remain aligned with design, behavior reflects system intent, architecture supports real needs. If you're interested in applying this step by step, we cover this in SSA's OOSEM training. See link in the description for our MBSE training. 8. Best practices and common pitfalls. Pro tips for effective traceability. Start linking early, even at stakeholder level. Focus first on critical and high-risk requirements. Use consistent naming so your generated matrices are readable. Review traceability at every major milestone. It takes almost no time in a model. Combine with attributes, verification method, rationale, status. Biggest pitfalls to avoid. Waiting until the end to add links. Do it as you model. Creating too many low-value traces instead of meaningful ones. Ignoring tool automation. Let the model do the heavy lifting. When done right, traceability becomes one of your strongest quality gates. Requirements traceability turns your MBSE effort from a collection of diagrams into a truly connected digital system. It closes the loop between intent, what you wrote, and realization, what you built and verified. This is exactly why structured approaches like OOSEM emphasize traceability from day one. It keeps everything aligned as complexity grows. Strong requirements plus strong traceability equals confident systems engineering. In the previous video, we focused on writing strong requirements. In this video, we focused on connecting them, because in MBSE, value comes not just from individual elements, but how they relate to each other. Traceability turns a collection of diagrams into a system model.
If this video helped you see how traceability fits into your workflow, drop a comment with the biggest traceability challenge you're facing right now. Hit like if you want more practical MBSE content. Subscribe and turn on notifications. In the next video, we'll build on this by looking at how structure is defined in MBSE, starting with block definition diagrams.